Good morning, everybody. This is going to be a short video describing the IP OSPF Prefix Suppression feature that is available on Cisco routers. Now, we will be talking a little bit about the network and the router LSAs, but I highly encourage the viewer to go independently look at these two topics. There won't be enough time in this, and they won't really be covered in as much depth in this particular topic. So for this particular topic, we are using the topology that you see up here on your screen. And it's very simple. There is a multi-access segment and there is a point-to-point segment. There are three routers on the multi-access segment, and you have R1, R2, and R3. The segment is numbered 123.123.123.0, and it's marked with a /24. There's a /24 subnet on it, and the IPs are .1, .2, and .3 for each router respectively. The point-to-point section is 34.34.34.0, and that's a /30. A point-to-point, true point-to-point segment with .1 belonging to R3 and the .2 belonging to R4. Each router also has a loopback IP, and it's XXXX for router X. Everything has been introduced in area 0, and we basically used a very simple command. We said network 0000, 255.255.255.255, and area 0 on every single router. So that's the only command that was applied. Everybody is neighbors with their adjacent routers, R1, R2, R3 in the multi-access segment, R3 and R4 on the point-to-point segment. And finally, there's no other manipulations that have been made so far. And finally, there is loopback-to-loopback connectivity. So on router 1, let's ping 4.4.4.4, which is all the way across on the other side, and we'll use source loopback 0 for those pings. So as you can see, they're successful. Now, taking a look at how this actually happens in OSPF on router 1, and let's try to keep the topology here up on the screen. Okay, so that's the topology up there. And on R1, let's now look at the OSPF database. So there are two types of LSAs here. There are router LSAs and network LSAs. Now for 4.4.4.4 and anything belonging to this side, everything should be in R3 and R4 router LSAs. So let's take a look at the R4 router LSA here. So here is the router LSA for R4. There are three types of links in here. There are two stub network links, and there is a link type 1, which is a point-to-point link in a router LSA. And again, the viewer is highly encouraged to go refresh themselves with router LSAs and the contents if they haven't done so in the recent past. So anyway, the total link 343434.0. The serial link is completely described actually by two link types in this LSA, and that complete information is the one that's highlighted here. So there is something for the SPF process, and that is this point-to-point link right here. So in this link, you are describing the neighbor that you're connected to, so within OSPF router ID and nothing else. So remember, this could be anything. This does not have to be an IP. So OSPF IP and the router ID can be decoupled very easily using just a router ID command. In this case, we just picked, we let OSPF pick the IP, and it happened to be 3333. But the thing to keep in mind is this is not an IP address. This is an internal OSPF data structure, and it happens to be 3333. So for the OSPF SPF process, this is all of the information that is needed. Now you also have the interface you are connected to them on, and the IP of that interface. Now, this only describes the router-to-router connectivity. OSPF actually uses a separate link type to describe the IP numbering or the IP addressing of that interface. And that is, it's described as a stub network. So if you look up here, this is a stub network link type. I believe it's link type 3, describing the loopback interface. So the loopback interface on R4 is actually a stub interface, and it is 4444 with a network mask of 255.255.255.255/32. And that's how OSPF actually introduces loopbacks. Doesn't really matter what their IP addressing is. And in fact, on R4, it is /24. But when it comes into OSPF process, it's actually introduced as a /32. That's the default behavior. But this down here now, this is another quote-unquote stub network, but all it's describing, if you take a look at it, is the actual IP numbering or the IP addressing of the serial 0 point-to-point network. So 34.34.34.0, and with a network mask of /30. So as you can see, this is only for the IP connectivity to those addresses. So if you wanted to somehow get to the addresses on that particular link, so your end intention was not to get to 4444, but it was to get to 34.34.34.4 or .2 in this case, then this would be needed. So the contention here is we can remove this information and still have end-to-end connectivity, and the way we remove this information is actually using the prefix suppression. So the prefix suppression command actually goes on the particular link that you're trying to suppress information from. So if I go to interface serial 00 here and I say IP OSPF prefix suppression, and there's you can either disable it or enable it, but if I just enable it, I say IP OSPF prefix suppression. Going back to R1 and looking at the same router LSA, that extra information for the stub network should now be gone. It is, in fact, gone now. Now, in the routing table, this information should still be there. So let's look at the routing table, show IP OSPF, show IP route OSPF. This information is still here. You have to realize R3 is doing the same thing. R3, which is the adjacent router to R4, in addition to other stuff, it is also describing the same link the same exact way. So for this feature to be successful, it has to be applied on both sides of the link. So let's go to R3. Let's go to interface serial 00. We're going to say IP OSPF prefix suppression. Now, the R3 LSA should be looking a little bit better here. So let's take a look at the LSA, and yes, so number of links is 3, and one of them is just a point-to-point link, the other is a stub network describing the loopback, and then a transit network, which we'll get to shortly. So now show IP route OSPF on router 1 or any other router does not in fact have the 34 network there anymore. So does that mean that we have broken connectivity? The contention is we have not. So let's ping the same 4444 using source loopback 0, and look, it actually really works. Because for the OSPF process, for the packet to go all the way to the end, the information 34.34.34.0/30 was irrelevant. The OSPF process does not really need that to be able to route packets successfully. So now if you wanted to ping those addresses for some reason, or you wanted to install a server or some services on those addresses, yeah, they would be needed. But think of, in a large network, how much less burden it is on the actual database if you were to remove all of the transit links. So now that takes care of the prefix suppression feature on the actual point-to-point links. The same feature can be applied to transit links or the multi-access links. And for that, let's take a quick look at how the multi-access links are described in the first place. So some part of it, so yeah, R3 would be a good example. R3 is actually the DR. It just happened to be a DR, non-deterministic process, but in this particular topology, the routers were all brought up simultaneously, and R3 was elected the DR. R3 is describing a part of the transit network in its router LSA. So in the router LSA, R3 is declaring that it is connected to a transit network. It will also tell you the designated router that has been elected on that transit network and your own interface address on that transit network. So the way the process works is would take this designated router address and should be able to find the OSPF process then should be able to take a look at the network LSA. So whomever was elected the designated router should be advertising a network LSA or LSA type 2 with that same router with that same LSA ID. So let's take a look at the database. And there we are. So this designated router address on the link is used to actually ID the LSA or LSA type 2 for that particular segment. So let's take a look at this particular LSA and see what's in it. So show IP OSPF database network and then the LSA ID. And as you can see, it's a pretty simple LSA. It has 4 parts that are relevant to us. It will give you the router IDs of each of the attached routers. That part is important to OSPF. Furthermore, it will give you the network mask of that particular segment. Now, the idea being you take this network mask, you combine it with the link state ID, which remember was the IP of the designated router on that network. So looking at the topology again, it is the IP of R3, 123.123.123.3 on that particular subnet. And that's how the LSA ID was created. So the LSA ID combined with this mask can then give the information of how the IP addressing is working on that particular segment. So now R4 is not connected to that segment. So let's look at the routing table of R4. And indeed, R4 was able to infer this information from those 2 pieces and was able to install the route here. So now if we did not need the route, we can actually make some manipulation to this network LSA here by applying the same feature, IP OSPF Prefix Suppression, to this fast Ethernet 00 interface here. So let's go ahead and do that. So F00, and we'll say IP OSPF Prefix Suppression. So now, right now I'm doing it on the designated router just to see the effects of it. But in reality, it should be applied to every single router on that segment if they had a chance of being elected a designated router. So until their priority is non-zero, this to future-proof the config, this should be applied on every single interface on that particular subnet. So let's look at this LSA again and if any changes were made to it. So on first glance, it doesn't look like there were any changes. But if you look a little bit more deeply, you will see that the network mask is now /32. So /32, it's describing a network of 123.123.123.3. That really does not make a lot of sense. A transit network cannot have a /32 subnet mask. So what happened to now the routing table? That's where the more interesting part is. Now 123.123.123.0 is gone from the routing table. And the reason is Cisco routers basically understand if the network mask is /32 on a transit and there are still further routers, so it's a legal transit network, that means the prefix suppression feature was actually used on the interface. So even though R2 has that information, since it does not have the proper mask, and in fact it has a mask of /32, and not a mask that can be actually used to install a network, it actually goes ahead and deletes that network, or basically does not install that network from the router LSA. So once again, this can be applied to every single router, although we haven't shown it in R1 and R2, but it should be applied to every single router that has an interface on the transit network, and the problem will be solved. So in a large network like a service provider topology, a feature like this is particularly helpful. I hope that you've enjoyed this video, and thank you very much.